Right. Hey everybody, thanks for coming out. Thanks to Ramel and Jeff for getting this together and your work in organizing. I've had a cold, so if I have to cough a couple times, please forgive me. I'm going to talk to you today about modern data management, give a little introduction about myself and Liaison. I've been here at Liaison for 7 years. We're a cloud data integration and data management company. So we grew up in the EDI space, kind of a customized van for EDI documents, and have kind of progressed from there into any kind of integration scenario, application, data management, and have a strong focus in the healthcare space, but across all verticals. So I get the privilege now with a few people here to work on a kind of a technology refresh of our data management platform, and we've been working on it for about a year, a little less, moving into next year, full steam ahead. And hopefully I can provide a few learnings from what we've been through. I think the talk is kind of a balance between the theoretical, philosophy as well as some practical stuff. So I tried to catch a balance between those things. This is kind of a small enough group that if you guys have questions, feel free. We can kind of talk throughout the presentation. If something comes up, let me know, and certainly we'll take questions at the end. We'll go ahead and get started. The agenda, I'm going to talk through kind of three main points about data management today. Most of you probably have a familiarity with the way this kind of thing was done in the past, and have a good understanding of kind of the legacy approach to data management, and kind of traditional RDBMSs and that kind of thing. And so now, obviously, we all know you're here as the Atlanta Hadoop Users Group, right? So you understand that there's been a lot of change. So I want to talk through some new assumptions that I think we can make when designing a data management platform now. Talk through some of the architectural principles that have kind of emerged over the last few years that I think build on some of these assumptions and present a new way of handling data. And then try to go into data management in practice. And I'm going to talk a little bit about some of the tools we've started looking into, some of the technologies we've been using, and kind of what's in our stack and what we're building out to hopefully give you some practical information on what you could do if you wanted to look into building a data management platform yourself. So first, new assumptions. The first one, I don't think it's a surprise to anybody here. This is pretty obvious, right? The idea that storage is practically unlimited, right? This is, moving on from the classic idea of expensive licenses, beefy servers, complex replication that's also expensive, to the more kind of open source commodity hardware distributed by design, right? This is kind of the philosophy behind something like Hadoop. So taking the assumption when you're starting out with your design that that you can scale out, it's going to be a lot cheaper than if you're running Oracle or something like that, and that can be a nice philosophical underpinning to what you're doing. Again, the notion of the way kind of storage has gone down in cost. I think this is a pretty telling graph. Again, it's probably nothing shocking to any of you, but the cost per gigabyte, which I just think is fascinating. Back around 1980, it headed up around $1 million. Can you imagine that? Scaling down to 2015 to where you're talking about a few cents, right? So we're kind of at the point where you can add, not free, but very cheaply, new servers, new storage, and it gives you a whole different approach, I think, to how you architect a design for a system than if you're worried about, how can I get approved for another Oracle license or replication, or what's the rack going to cost, right? So that's my first assumption. Again, nothing shocking, I think, to any of you guys. The second one, I think that is interesting. We were talking about this a little bit earlier. Is the idea now that I think you can look at schema and data as being decoupled. And I'll tell you what I mean by that. Data is not its schema, and it doesn't have to be stuck in a single shape or model. So this is kind of coming from the previous classical idea that, when you think of data, you think of a relational table, and the schema and the data is fixed. It is what it is, right? and you can't really get away from that. So at this point, though, I think we have enough options and enough flexibility with the type of tools and technology that's out there that you don't have to have your data kind of stuck in a single model. And I think there's two different ways that you can think about structuring your data. I think there's the idea of a data model, which you can either discover based on the data that you have, or it can be applied to fit a particular use case. The model, I think, is that's going to talk a little bit about what are the fields that you have, what is the metadata around the data that you have, and then finally there's structure, and I think the structure can be variant and use case specific. So by structure, I mean that you can take something that's modeled in a particular way, and you can place it into a different type of storage mechanism or structure, and that can be used to based on performance, right? How are you going to best find performance from your data from a particular structure? Obviously, there's the classical kind of tabular and relational model. You have a tree structure, be something like XML or JSON, kind of fits that tree structure. Graph, there's Neo4j and Titan and other graph databases out there. Mutable log, inverted index, Elasticsearch, that kind of thing. So if you look at, I think we have to start thinking about these pieces as being decoupled and not thinking about them being married in one thing. I'm not saying that schema is not important. Schema is very important. We were talking about that earlier. You can't have, I think, a functioning platform without schema, and I'm glad we talked about this earlier because I think it's really important that when I think all of these new technologies came out, and you had this notion of like the data lake, which I think is just the biggest fallacy because you can't have this kind of unstructured set of data and expect to get any useful information out of it. Any tool that claims to be schema on read, you still have to have some form of schema and knowledge of it ahead of time. So I'm not saying throw a schema out. What I'm saying is that let's not think about it as being tightly coupled with the data. Let's think about it as being something that you can model, can discover, can structure, and can vary based on what your use case is. And here's, I think it's kind of an example of this. I hope kind of breaks it down maybe a little bit better. So we have data. These are the actual values. This is the information, the hard facts, the business data that you have. John Doe, 123 Elm Street. Without a model, this data is fairly meaningless, right? I mean, you could probably infer what it is, but a computer is not necessarily, at least at this point, going to be able to infer this. You could do some natural language processing and do some part of speech tagging and maybe come out that John Doe is a name, right? But I mean, at the end of the day, you still need something to describe it. And so the model is going to tell you what these things are. Okay, John Doe, it's got a key, the field name in its name. You have address, you have phone. It has types. Is it a string? Does it need to be an integer? For phone number, maybe it's a customized type. Maybe there's a specific phone number type that it has to fit, right? Is it a required field? And you can have a whole lot more. I mean, anybody that's done anything with schema modeling knows that there's, a dozen or more fields that you could have about any particular part of your data. So the model kind of describes what the data is. And then I have this notion of the group, right? I think the model also infers relationship, which is something that's inherent to data. If you just have a bunch of fields spread about, it doesn't have much meaning unless you have a relationship between those fields and how they interrelate. So maybe this is a record or an object or a class or a struct or whatever you want to call it, right? This is a grouping of fields that has a categorical set of information. And that relationship is important and is defined by the model. When we move on to the structure, I think this is where you take what your data is based on a model, and then you can present it in a different type of structure. And each of these structures has their own way of handling relationships. And each of these types of relationships and types of structures provide a way of maybe faster read access or faster write access. Maybe it's something that's more fine-tuned for free text search, right? Like an inverted index would be a horrible idea to use if you have highly relational data and you need to get insights out of it relationally. But if you need to do free text search, an inverted index is going to be perfect and performant and fast, right? So we need to take the notion that you don't take a single set of data and kind of force it into one thing. Let's let it be available for what the use case is. So a couple examples, JSON up there, you've got a nice kind of tree structured data, very nice for representation, maybe not the best for query, right? Maybe a relational or tabular type table. And then finally at the bottom, maybe a graphical. Maybe you want to have nodes for name and address, and they have edges for, John Doe has address Main Street, and maybe other people do too, and you can run queries off of that. This is use case obviously in social media, Facebook social graph and things like that. So, does that kind of make sense to you guys? Is that clear? Like, I think just the notion of let's separate these, let's not think of them as one thing. That was kind of a revolutionary thing to me, that it's not, data is not a structured table, right? Yeah, one other thing I wanted to say here too, I think the importance for models, you can use a model for correctness. The importance of a model is that you have correctness, you have validation, safe transformation. It's good for that kind of thing. It's good for human understanding, for categorization of information, so that humans can look at it and go, oh, okay, this is a person. This is information about a person, right? I know about what I know, right? Which is important. And structure is, as I said, much more, I think, for application processing. Putting the data in a format that a machine can understand and process in a particular way.
So if I'm listening to you, you're saying that storage is cheap and you should store your data for access pattern-ish, right? Right?
Yeah.
So, and you could do it multiple times, right? So if I have a search use case, I might have the same data set that's stored in Elasticsearch or Solar. And if I have more of a graph use case, I may store the same data set and whatever, right?
Yep, absolutely.
So that brings to the next question then. That becomes a little bit tricky from old school DBAs who want to have one single source of truth. How do I manage the permutations and potentially multiple places where the same data set's updating? Do you keep like a canonical version of the data in some format forever?
Yeah, and that's what we're doing. And I'll get into that a little bit more on the practice side. But we have a canonical version of the data. And then we have the idea that the data is being populated out to these other systems, and I'm going to go into that a little bit too. So, but yeah, that's a good point. I think that's important. Okay, so that's my second assumption. Let's go to the third. My final assumption here: data is not always finite. I think this is something that people are understanding more and more. We were talking earlier about stream data coming from automobiles, right? I mean, there's dozens of use cases for that sensor data coming in. You don't have a time where you go, okay, my data is complete. This car is no longer sending me data. I've got my set, right? It's infinite. And so I threw this quote up here. I think it's a good one. It's from Google's paper, the data flow model. It's a paper that came out, I think, earlier this year. It's a good read if this is something you're interested in. But essentially, as a field, we need to stop trying to groom these unbounded data sets into a finite pool of information. And instead, we need to change our way of thinking and live under the assumption that we will never know if we've seen all the data. Just the data is going to arrive, it's going to be retracted, and we have to make some decisions about how we handle that, right? So I think this is an important part of any kind of data management platform. You can't go by the old assumption that you're going to get these nightly batch jobs and here's your chunk of CSV files and it's done, right? You're going to have those kinds of things. They're never going to go away, right? But more and more, we're going to be dealing with use cases where streaming data is going to be the norm, and you're not going to know when your data set is finished, and you're going to need to have new abstractions and new ways of dealing with that. So,
does that mean you don't care about data loss as much as you do in other cases?
I think it depends on your use case. Again, it depends on what you're bringing in. If you're bringing in,
if it's financial data, I understand, but if you're bringing sensor data,
yeah,
you lose a little bit. So what?
Yeah, I mean, if you're bringing in like temperature readings or something like that, and you lose a few of the seconds that comes through, then you're probably okay. If you're maybe taking in sensor data from meters on houses, which you're billing your customers for, then maybe you don't want to lose as much.
We do an enormous amount to try to, we are on platinum systems, to make sure we never lose data on things that really don't apply. This is a good maybe a good point there.
Yeah.
And if we have sensor data coming in, if we lose some,
Yeah.
we want our systems to stay up, but if we lose a little data, so what?
Yeah, and I think
Why your idea of storage being cheap doesn't apply to companies like ours, because a lot of times we have to do EMC storage, which is 10 times as much as this stuff.
Right.
So they're going to force it. They're going to say, if you really want it to be 100% there, that data, we can't take it.
It's like that last point, right? You can always sort of trade throughput for durability, and like doing the very last line, correctest latency costs, right?
Yeah.
Just gotta figure out what you care about.
Yeah, I kind of skipped over that, but that's a good point. I mean, when you're making these decisions, you do have these trade-offs. There's no silver bullet. Like, if you didn't know that, I'm sorry to break it to you, but there's nothing that's ever going to be a silver bullet, and so you always have these trade-offs. And I think this is a good one when it comes to this streaming data. And again, this is a great paper written by people way smarter than me, so go read it, and they'll give you a lot better insights. But yeah, I think you have to make those decisions as you're looking at what you're doing. And for us, we're kind of a very generalized platform. We need to be able to handle all sorts of use cases, right? And so we kind of have to be able to have built into the platform the ability to make those trade-offs. Because customers are going to come and go, I can't lose anything.
Right.
And others are going to say, well, yeah, I'm doing kind of a rough analytics collection, and if I miss a few data points, it's not the single points that matter. It's the, it's the overall chunk that matters, right? So, okay, so that's the end of my assumptions. Move on to some architectural principles. And so these are some things that are not created by me that I'm going to talk about. Most of these are all ideas in the community from people out there that have written papers and done talks. But a lot of this you may be familiar with. But I wanted to kind of summarize these as, I think, reflections of what these assumptions are and how they're manifesting themselves in the real world and what people are doing with data systems now. So the first is reactive systems, and this is the reactive manifesto that many of you may have heard of. This is, I think, kind of popularized by TypeSafe, the people that do Scala and AHUG, and it's definitely, that's the philosophy that they kind of have built the TypeSafe system on. But I think it still has some really relevant details for any kind of data management, or really any software system as a whole. So reactivemanifesto.org, it's a short read. It's one of those things you'll read through and go, duh, but it's got a nice way of framing it. Essentially, there's 4 points that they talk about. Reactive systems are responsive. They need to respond. They shouldn't go down. There should be a response in a quick and timely manner. They should be designed that way to make sure that they're always available as much as possible. I'm not going to talk about CAP theorem tonight. There's resilience. They should be able to withstand issues, withstand errors. They should be able to bounce back, to have back pressure. They should be able to have a very elegant way of error handling so that they can withstand any number of possible issues in the wild. Elastic. They should kind of expand and contract as needed. Again, the idea of back pressure, that if a system's getting hit really hard, that component should be able to provide some back pressure to scale so it doesn't get hammered and taken down. The system should kind of breathe. And finally, message-driven, which I think is very particular to the architecture that TypeSafe uses, kind of based on actors, or the actor model. If you're familiar with it, it kind of came out of Erlang. The language has kind of the originators of the actor model. Essentially, it's a framework for handling concurrency, and it's the architectural approach that the TypeSafe platform in AHUG uses. So that's a little more specific to their particular architecture, but I think the responsive, resilient, and elastic give us a lot of ideas about how we need to design our applications. Again, nothing earth-shattering, right? It's just a way of framing some important points about what we're working on. And I think it kind of, we have this because, storage is unlimited. We do have these large amounts of data, and it's not always finite. So we need to design systems that can ebb and flow with that. The next one is the concept of polyglot persistence. And this, first, as far as I could find, the term was first used in 2008. And it was based on the Neil Ford's notion of polyglot programming, which most of you probably familiar with, your developers. The idea of polyglot programming is pick the language for the job, right? Java may not solve all of your problems. Maybe you need to use another language that's more specific to a particular use case. And so similarly, that term was applied to persistence layers. With the influx of different technologies out there, you're not, you don't have to just use an RDBMS, so you can use whatever different kind of persistence layer. So choose the right persistence option for the job. So this goes back to my initial idea of storage being unlimited. You can kind of pick your persistence layer, and as we were talking about, Jeff, you've got these different endpoints that you can now store this data in and use it for the type of use case that you may have. And obviously, the more flexibility you have, the more cost you have. I think that's going to be a theme through this. That's, again, another one of the trade-offs you always have. The more flexibility you have, the more complexity. But it pays off when you have specific customizations that customers need without having to try to force something into the wrong tool. So here's an example that came from a paper Pramod Sadalaj, I don't know if I pronounced that right, and Martin Fowler wrote about polyglot persistence. And I think it's pretty obvious, but it's a nice, I think, view of it. Their example was if you have an e-commerce platform, you have different types of data passing through that platform that have different needs, right? And so your key value store may be your shopping cart and session data. You may have a document store to store, kind of the repository of all the completed orders. RDBMS is not evil all the time, right? You still have a good need for this when you have, maybe inventory and price data. When you do, it's very good at relational type queries and things like that. So let's use it where it makes sense. And then maybe you have your customer social graph. Maybe you want to be able to have recommendation engines and things like that. So you have a graph store to do that with. So again, pick the technology that fits your use case and your need. Okay, the next architectural principle is the Kappa architecture. Many of you may be familiar with this who have worked with Kafka before. This has been a big thing in recent years. Jay Krebs, who is one of the, actually he used to work for LinkedIn and now works for Confluent. And so they have their entire platform kind of built around this notion of the immutable log. So it was kind of, the original paper was kind of Krebs proposing an improvement on Nathan Mars's Lambda architecture. For those that aren't familiar, the Lambda architecture was trying to grapple with the fact that, like I said, we have batch jobs and we have streaming jobs. So how do we handle this? And his notion was you send the data through two streams, and you have your batch processing engine, and you have your stream processing engine, and they both process the data at different times, right? It's a good idea and a good start, but the problem then is you have application level code that you're keeping up in two places, right? For your batch job and for your streaming job, and how do you handle that? So Jay Krebs was proposing a different approach to this using Kafka as an immutable log, where your data comes in and then you can actually send it through these different streams to a particular database where the queries can come in. So you don't have to have separate logic in separate places. You can use the log as the single store for your data. I think this idea is pretty revolutionary, and it's been, it was even further extended, I think, in this talk by Martin Kleppmann. If you take nothing away today, take this away, go watch this talk. Martin Kleppmann gave this talk at Strange Loop 2014. And it's fantastic. It's got a transcript as well if you prefer reading, but the video is out there. Essentially, he talks about, it's called turning the database inside out, Apache Samsa, and he talks about this notion of, databases have been doing the idea of an immutable log for years, for a long time, but it's internal to the database and it's an implementation detail. And so let's turn the database inside out and let's pull this out as a first-class citizen in our data processing platform. And now you can bring data in and you have this event stream that's immutable. Anything that happens at any point in time doesn't change, which I think is another key architectural principle that shifts the way you think when you kind of wrap your head around it. That anybody that's done Java or object-oriented programming thinks about you have a value and you have immutable state, and the object changes But it's not the object that changes. A value in a particular time is a value at a particular time, right? It's new values at different times that happen. And so the log kind of captures this notion to where you have immutable values happening over time, and the fact that pizza is my favorite food today doesn't change if my favorite food tomorrow is hamburgers, right? So I don't get rid of the old data. I persist that in a log fashion that can be replayed at any time, so that if you have different systems now that need to get up to the same state, all they need to do is replay that log up to the same point, and they are now at the same state, right? So it gives you a nice abstraction to keep different applications in sync. And so he took this idea and said, okay, so now that we have this great notion of this immutable log, let's have it write to different materialized views. And this is the notion of bringing in these different endpoints that matter, the Elasticsearch, and our DBMS, our graph store. Now you have the same kind of core data that you can take and you can process the different materialized views for what the use case may require, right? So I can process data through a queue, through a log, and I can update my materialized views. I can have these guys listening from the beginning, and then tomorrow somebody says, I need a graph store. Okay, let's add it. Let's replay the log from the beginning, and now they're in the same state. It's not a problem, right? What if this guy goes down for a day, right? He hasn't lost anything because it's being stored here in a replicated immutable log. He can catch back up. So I think it's a design pattern that's proving to be very powerful, and one that I think should be a part of any modern data management platform. All right, my next principle, again, this one is not cutting edge or shocking, but microservices. I think it's helpful to have a microservice architectural approach when you're dealing with this level of customization and this amount of flexibility in your system. So this is from a paper Martin Fowler wrote on microservices. I think it's a pretty seminal paper in understanding microservices. It's out there on his blog if you're interested. But it basically takes the idea that in a monolithic application, you put everything in one process, all your functionality in one place, one big box, and then you get scale by replicating that out across different servers. You just put that one big box on these servers. Versus microservices where you put a smaller component, element of functionality in a box, and now you spread those out as needed. And maybe the green triangle is getting hit harder than the purple shape, and so maybe you have more green triangles than purple shapes, or whatever it may be, right? It gives you some segmentation on what you're doing. And I had to throw this next slide in. The joke is always that this is what you end up with when monolithic is a big pile of crap versus a bunch of little piles of crap. But I just thought that was funny. This is from a presentation Alvaro Sanchez did, and I just had to throw it in because I thought it was funny. Yes, we know. That's why we all have jobs, is because this is how it always ends up, right? Okay. But there are some benefits to microservices. The first one, componentization via the services. This is how we program, right? We design components of functionality and we put them together. We design libraries that do a specific thing and we put these pieces together. Because as humans, we can't hold everything in our head. So we have black boxes of functionality that we can plug in together. Microservices plays into that way of thinking that just as humans, that's what we do. The next one is they can be organized around business capabilities. And so you can take people that across roles and apply them to a particular business capability to get a better result than if you're only working within one team. There's a pretty famous quote many of you have heard. It's called Conway's Law from 1967. Any organization that designs a system defined broadly will produce a design whose structure is a copy of the organization's communication structure. So the systems tend to represent what our organizations look like. And the microservice approach helps you to break that a little bit and organize around the business capability as opposed to I'm a DBA and you're a programmer and whatever, right? Smart endpoints, dumb pipes. You have the pipe shouldn't be doing the thinking. I hope that the classic ESB and service bus thing can just die. No more web methods installations. Anybody that's worked on that might Might be happy about that, right? Let's not make our pipes be the smart things. Let's make dumb pipes and let's have smart endpoints. And I think this plays into the Kappa architecture as well, where you have the immutable log that's kind of serving up these endpoints. So it's not a new concept, right? I mean, Unix has pipes. You can pipe output of one program into another, right? It's nothing new, right? This is something that's been around for a long time, and I think it makes a lot of sense. Microservices facilitate that. Decentralized tools and data management, right? Plays into the polyglot persistence and polyglot programming notions. Maybe a particular service is going to be better served using a particular language or a particular persistence mechanism. You can do that a lot easier with microservices than you can do with a monolithic application. Again, you're trading flexibility for complexity, but there's some ways that you can help with that. We'll get into in a few minutes. The main way you can help with that is my final architectural principle: continuous delivery. I think if you're using microservices, if you're doing polyglot persistence, if you're doing any of these kinds of things, you have to have a good continuous delivery, DevOps, whatever you want to call it, strategy. There's no way you can manage that complexity with one guy that knows everything and has to get up at 2 in the morning every day to bounce the server because he's the only one that knows how it works, right? You have to have scripted components. Let the documentation about how to deploy a new system be the actual code that deploys it, right? Let's build tools to deliver our system. So this plays into everything from kind of the traditional continuous integration, having a build tool that knows how to put together your build and compile your applications, run tests, infrastructure automation, and then the methodology to be able to provide frequent releases. You may see the sign on the door over there that says, we need to deploy to production 10 times a day. That's Brad, who couldn't be here, the other organizer. It's been his mantra. We're working very hard to be able to get into a place where we can deploy to production multiple times a day. We're not there yet, but that's where we're trying to move to, right? Keep your features small, keep them easily testable, have a defined process that's automated, and get it into production quickly. So that, how many of you have done a release into production that's been a month worth of coding and it's done over a weekend and everything blows up and you have no idea where in the code it is, right? It's a nightmare. Let's deploy a smaller unit of work that if it causes some issue, I can roll it back. I can go fix it and put it back into production in 5 minutes, right? So that's the build, test, release automation, being able to rapidly deploy to an environment, which not only helps with deploying to like a production or a UAT environment, it also helps in development. If I can spin up my entire infrastructure in Google Cloud to troubleshoot a bug, how much power does that give me as a developer to solve something or to test something out?
That's a very good point, Matt, because in Hadoop, the cost to fail in Hadoop is extremely cheap. So it doesn't introduce any sort of friction or risk in terms of releasing early, releasing often, right? It follows basically what Apache software and Foundation is doing. That's a lot. Release early, release often.
Mm-hmm.
So continuous delivery is like a perfect match for the Hadoop environment.
Yeah.
Because the thing is, you can build small set of code, deploy it, test it right away, and then you can iterate to it.
Yeah. Yeah, absolutely. And what this fosters is innovation and experimentation, right? You're not terrified to build something new or to add a feature, you know? You're not afraid of what you're going to break. You have a little bit more freedom as a developer to go in and innovate and experiment with what you want to see in production, right? I think it gives a lot of confidence to the team and eventually to the organization as a whole. So that's something that we're shooting for right now and trying to change culture. If your organization does it the traditional way, this is a culture shift. It's very big to try to change.
And the only thing I'd add to that too is it allows for developers a sense of parallelization. You're not all fighting over one test environment. If you can spin up the whole environment in a dev area that's just yours, anytime you want to, it looks just like production does, but you're not fighting with other people for other resources and time on the system and things like that. So it gives you a lot more throughput.
Yeah, absolutely. So yeah, we're already seeing benefits to this, and we've just kind of recently started to adopt this. Not perfectly, but it's coming along. So this is kind of a quick diagram. I wanted to throw it up here so I'm not all theory. I wanted to be a little bit practical. This is actually a drawing I did of our process currently and what we're trying to do. And the notion is here that developers should be able to iterate very quickly through forking a repository. We're using GitHub, so we're doing kind of the GitHub flow for managing our code. So we fork a main repository, we do the work in the fork, and we have this set up with our build tool. We're using TeamCity to trigger off of pull requests. And we have a whole system set up to where we can take a particular code that's been written and committed to a pull request or to a fork, and we can kick off an automation that will deploy that into GCE. So with the click of a button, we can deploy our entire platform into GCE, and it'll spin up in a few minutes. And now I have my brand new feature that I just coded that I can sit there and hammer and test and run load tests on and take metrics and see if it's working. We can also spin this up for integration tests that are automated. We can spin up an environment, we can hammer it with integration tests, spin it back down, and see if we cause any issues or any problems based on our code change. And then this goes all the way through. We do have peer reviews and QA reviews of our code before it goes in. We do have some manual steps that people, we're not just click button code to production. We do have some manual steps for compliance to go in and do reviews. But by the time you get to this point over here that it's ready for production, that it's been reviewed, it's been tested, we've got metrics, we've got static code analysis, we've got integration tests, everything's looking good, you've got all your artifacts. And the change control board can go, okay, cool, and you build up that level of confidence to get it into production. So quick iteration for developers, quick release cycle into production. Is kind of the takeaway from that. Okay, so that kind of leads into data management in practice. So I'd like to kind of go through a little bit of what we're trying to build here based on these principles, based on the assumptions that we've made, leading into some of the kind of theory that's out in the world today about how to build a platform based on the current needs of data. And so I'm going to go through some of these. Hopefully this is useful to you. Hopefully it's practical. I tried. Okay, so first, the persist, right? Choose your persistence layer. Almost certainly we'll have an RDBMS. So you have a column family type store, HBase or Cassandra or something like that. MongoDB for document storage. This is the TitanDB image for graph. A distributed cache, inverted index, and Elasticsearch. Right? Pick the use case for your need. So how do you get these populated? How do you handle that? Well, and that's where flow comes in, because data flow is going to be very important through this. Obviously, the immutable log, Kafka being at the center. Something else, just to throw a MapR plugin. Sorry, guys, but MapR's got a new MapR Streams, which I don't know if you've heard of, but it's kind of their answer to Kafka, and that we've played with a little bit in some beta testing. It's pretty cool stuff. But the idea being that immutable log is kind of at the center of what you're trying to do. So flowing through your immutable log and then getting processed by a stream processing system. Kleppmann talks about Samza. It's a stream processing framework. We are using something for our data flow called Onyx, which is the O there. It is a stream and batch data processing workflow engine written in Clojure. And we've been using Clojure for the past few months or so for building out our system, and so Onyx was kind of a nice fit. If you haven't used Clojure, I'll put a plug in for that too. Really enjoyed learning it. So both of these are kind of data processing platforms. So to go back to your question, Jeff, from earlier, the way we kind of handle this, we have kind of your canonical storage, your kind of golden record in HBase. So we kind of keep up with all the records in the history in HBase as they come in. And from there, we have a change queue, a delta queue. So as the message flows through HBase, these populate the delta queue, which you can attach these different listeners running data flows on that can take it and push it into Elasticsearch, or take it and run some processing job. And they can be customized for whatever you need. And it's getting updated in near real time, right, as the data is coming through. So yes, you still have some coding here. You still do have some processing that you have to be able to handle. The idea, though, is if you have the microservices that can handle these pieces, then you're flowing the data through, processing it through whatever kind of crunching you need to happen, and pushing it into the storage technology that's going to make the most sense for your use case. And so that leads to the microservices. We're using Finagle, which is a Twitter open source library written in Scala, where we're using a kind of a closure wrapper around it. And it's very nice, asynchronous RPC system. It uses Thrift as the protocol, which is a message serialization tool, kind of like protocol buffers or what's the other Apache one? Avro, yeah. And so it does the message serialization, but it also has a RPC generator as well, so you can generate your clients based on it. It's a pretty nice system. So we're using that for our microservices, which handle processing along with these data streams and stream processing frameworks. So the next piece here is is to scale, right? And so we're using Mesos and Marathon. Has anybody used Mesos or Marathon? Very, very nice tools. Essentially, they allow you to manage your data center as if it's a single machine. They allow you to deploy different instances of your application, keep them up and running, do hot deploys, rolling updates. It's kind of like if you took Yarn and extended it to the data center, right? So we're using that not only to handle our dynamic deployment, but also to be able to kind of breathe, scale in and out, right? Maybe a particular service is getting hit really hard, and you meet some threshold that triggers Mesos to tell Mesos to deploy a couple more instances. So now you've got 4 instances running instead of 2. Maybe another service is having a little bit lighter load, so let's scale it down a little bit to free up resources for something else. So the principle here is our system should breathe, right? It should kind of expand and contract as needs come in. And you should be able to do a rolling update to a new service without having to do it during a change window. That kind of comes into the deploying to prod multiple times a day. And then the other logo is Console. Console is a service discovery tool built on Surf, which is a gossip protocol implementation. So we use that for service discovery, where basically a new service comes online and says, hey, I'm here, I'm at IP whatever, port whatever, and it gets populated out to all the console nodes via the gossip protocol. So now when my other service says, I need service A, hey, where's it located? It can tell me, and I can go out and find that, which you have to have some kind of service discovery mechanism if you're doing microservices and you're doing this kind of dynamic approach, because the Mesos and Marathon is going to deploy to whatever IP, to whatever, so you can't just put a config file out there where my other service is, right? You've got to be able to know where it is because it's a living and breathing environment. Yeah.
So with those 3 different pieces, console,
Mesos and Marathon.
Marathon, yeah. So do they have this concept of like redundancy support to infrastructure?
You mean within like
within, let's say within Mesos. Does Mesos have the ability to replicate itself to service the entire data center?
Yeah, I mean, so you would probably set up Mesos running on redundant servers.
So the hardware, not the software.
Yeah, I mean, so I don't know that you wouldn't scale out Mesos itself, would you? I mean, Mesos you would basically install on a set of redundant servers, and then it would be kind of your core for handling deploying your applications across the data center and scaling those out. I mean, essentially what you do is you say, here's a path to a zip file or a Docker container or something like that, and here's the command to start up my application. And here's how many CPUs it needs. Here's how much memory it needs, whatever. And Mesos will say, okay, I've got this space over here. I'm going to deploy this on this server with this amount of, this many resources, and I'm going to run this command to start up the application. Right. So again, think about Yarn, but think about it for like an entire data center, not just managing like Hadoop jobs.
You're not running HBase on Mesos, right?
No. So actually we're using MapR, so our MapR installation is actually being done separately. We have it scripted with Ansible and stuff, so like we still have like kind of the automated ability to deploy it, but we're not scaling that with Mesos. At this point, if we needed to add a new node, we need to call Miaser's team over in TechOps and have them help us out add a new node, right? But that may be something we get to someday. I think we're focused more on our application at this point. But yeah, that's a good question. So the next part here, create. And I called it create because, again, this is the flexibility of a continuous deployment that allows you to create. It's a lot of work up front. But once you kind of have something up and running, it frees you up to create new features for your customers instead of having to constantly manage new deployment or constantly having to worry about how do you deploy these new features to production and get these things done. And, worry about servers going down and all of that kind of stuff. So we're using TeamCity as our kind of continuous integration and build tool. It's a JetBrains product, people that do IntelliJ. We found it to be a fairly flexible tool, so we're kind of in the process of using that. Currently, we're using Sonatype Nexus as our internal artifact repository, and then we're using Enterprise GitHub for our code, and a lot of our workflow and SDLC is based on GitHub and using issues and pull requests and forks and that kind of thing. So a quick example of what I mean as far as the deployments, and I think I kind of explained this, but the notion being that I can kick off and say, I want to deploy an update to Service C, and we have a kind of manifest that represents what's in the platform. I can send this through, and we have a tool that we call Scotty, after the Star Trek character. But Scotty takes the manifest, parses it, and then is responsible for communicating with Mesos Marathon Zookeeper, and it pushes it out, right? So it would do a rolling upgrade and say, okay, I need to update C. It's saying C is version 1.2. It's 1.1 out there currently. So let's upgrade it. Let's take down the one on server 1 first. Spin up a new one, and then kind of roll through them so that we can get the entire service upgraded to the new one in real time without having to take anything down or having any downtime. So I threw that in as kind of an example of how that looks. So that kind of builds the full picture of what our platform is and how it interrelates. Taking in some of those principles, kind of the key streaming processing in the middle, microservices, a polyglot persistence approach, handling stream, and then having really solid tooling in there to orchestrate it, to manage it, and to maintain it. So that's pretty much it. Thanks, guys.
That's cool. Thank you.
Thank you.
So is there any other questions or anything for me before we do it?
So you said that you have the SAMSA slide up there. Have you guys been using that in production?
We haven't really. We've experimented a little bit with SAMSA. We've kind of moved over to using Onyx more as a data flow and workflow tool. That's not to say that we might not go back to SAMSA at some point, but we found some other approaches at this point.
So Matt, if you can maybe upload the deck to so like
Sure. Yeah. Okay. Yeah, I'll upload the deck, and there's some links in there and stuff, as I mentioned, for you guys to take a look at if you want. Cool. Thanks, guys.
Thank
All right,
you.
thank you. It's good. Thank you. Thanks, Matt, for the presentation. Great presentation, by the way. So, Jeff, would you like to talk about the next presentation?
Yeah, sure.
Just to give this guys a brief overview.
Yeah, absolutely. Cool. Yeah, thanks. I thought that was a really good talk, and mirrors like a bunch of the stuff that I see, anyways, in the field. So the next talk that we're going to do is after the new year, in January. I think the 19th is when we decided to do it. 19th, it'll be down at the Atlanta Tech Village, which is at the it's 400 and Piedmont, like next to. I don't know. Buckhead Church, or there's a Chipotle like down right there, like right across from Linux Mall or whatever. But we're going to be talking about Apache Kudu. This is a new project that was recently donated to the Apache Software Foundation. And so we'll just do a kind of intro and getting started with Kudu. We'll hopefully by that point have some code examples. I expect there to be a pretty reasonable turnout there because we're going to combine it with the Atlanta Big Data Science Group as well. They're invited, so there'll be quite a few people there. So it'll be a good chance to network with people. Yeah.
It's basically like the intersection of.
That's right. Oh yeah. Just to give you a background of what Kudu is. Yeah. So Kudu is like is designed to fit in the middle of where you have HDFS. It's really good for doing really fast scans, right? And then you have HBase, which is good for doing updates, number one, but also single row lookups and really fast writing, right? And Kudu is sort of a different storage engine. Like HBase sits on top of HDFS, but Kudu is its own storage engine and is meant to kind of be not quite as fast as HDFS for scans and maybe not quite as fast as HBase for single row lookups, but it basically gives you a similar sort of scan performance as HDFS, a little bit less, but it gives you the ability of updates, right? And ultimately transactions and things like that. So we'll talk about all those, the reasons why we wrote Kudu. It's a project that's been in progress for almost 4 years now. Ever since I started Cloudera, they were already started on it, which is pretty cool. And talk about some of the reasons why CPU changes, et cetera, et cetera. So I think it'll be an interesting talk. I encourage you all to come. And slight other plug. I also, if there's anyone here who uses Kafka or knows about Kafka, I also run a Kafka meetup. If anybody wants to present at the meetup, I'd love to have customer presentations. I don't ever want to do another Kafka talk. What's that? Yes. Yeah, I know you.
Thank you.
That's
Thanks,
all,
Jeff. Yeah, and the other presentation at the end of January is NiFi. I don't know if you guys heard of NiFi. It's short for Niagara Files. So it basically is the real-time data ingestion. So Matt talked about making the pipe dumb and the endpoint smarter. So NiFi fits into the dumb pipes, right? So NSA actually started developing this about 8 years ago. They donated it to Apache. So we have a guy coming in at the end of January to talk about what NiFi is and what is it good for. So it's cool stuff like Kudu. NiFi, there's a lot more in incubation that we could probably pull in some folks to talk about. So we'd love to see you there. And if you have any suggestions, by the way, we'd like to hear from you. Today, do you have anything in mind that you think we should be presenting? We'd love to hear that. Or any ideas.
Any ideas?
Any ideas.
We're like the new organizers. We're all fresh, full of energy.
Sky's the limit.
Right?
Yeah. So
Anybody?
let us know.
Sure. You have something you
Yeah,
want to say, Jeff?
I'd like to know if you, I was going to ask you later on this, but different experiences people using their dev environment, using Google Cloud or Amazon Cloud or some other way to scale up quickly.
Totally.
And, what are people really doing? It's like we've tried a few ways, in some ways stink, but we've done it internally. Okay?
It's very diverse from what I've seen so far from different organizations. Some have preference to Azure, some have preference to AWS, and some have preference for Google Cloud, and some have preference for Verizon because they have their own infrastructure and rack space, right? So, and I think the reason why they have their own preference, it's driven by the existing relationship that the management has.
Totally.
But we, as techies, right, we're bound to what the management decides. But if you're an organization where the IT folks actually make recommendations, then that's great, right? You can pick whatever you want. Did that answer your question?
I mean, I think that there's a reason. So I think from what I've seen, it depends upon the type of organization that you are and if you're okay with your data being in the cloud, period, right?
Right. That's
So
what I wanted to see what other people have
So-
that problem.
Places where I work, which is mostly banks,
Yeah.
they don't have stuff in the public cloud.
Okay.
My opinion on private clouds right now, I think I was saying this earlier, is there isn't anything that's totally 100% baked like EC2 for private cloud, right, or AWS for private cloud. And that's why you see people moving to AWS is because You can automate provisioning, you can spin things up quickly, you can store things in like a long-term bucketed storage and just use ephemeral storage when you need it. That kind of capability currently doesn't exist in like a totally baked way, private cloud-wise.
But are banks using AWS for the development operation? Are they willing to do that or not? They're saying, no, I'm not going to put my data there at all.
No.
Okay.
Yeah, so companies who's got sensitive data, they don't want to put that in the cloud.
Okay.
I'm not saying that's right or wrong.
No, I understand.
I'm just telling you that's what I see. I don't see people
We
doing it.
spend half our day just dealing with security. I mean, that's
Yeah.
It's their
Yeah.
job, compliance.
The only company that I think of that hosts sensitive information. Now, sensitive information could be under the bounds of PHI, PCI, PII, but other companies, they have their own definition of what's sensitive outside of that.
Right,
Right?
there's just maybe company confidential stuff that isn't
Exactly.
sensitive. So it's not consumer data, which I
Right.
understand why they want to stay away from that.
Yeah.
But you might have things that just maybe equipment that exists in different companies.
So Rackspace, they have a private cloud infrastructure,
Yes.
which one of the big four firms, and they consider data to be all sensitive, uses them.
Okay.
So they put their data there. They're actually looking at deploying their infrastructure in Rackspace.
The only, I think, the caveat I would put is the migration is more on the test and the dev environment on AWS or on Azure or on a public cloud. But the production might still reside there.
No, the production's, it's okay to have a production. I understand that would be all secure and all that.
But the test,
But do a lot of people, even if it's just test data, because you got to put, initial data in there to begin with.
Yeah.
And you probably want to copy something, maybe disguise it a little bit, but copy something like your actual data into the cloud. I mean, are people willing to do that, or are they saying they're pretty much even backing off on that from the dev?
I still see people use VMwares. Right? They still spin up like it's easier.
But
to
that's
provision.
internally, right? So you
That's
don't need
internal.
VMware, and I
Yeah.
understand
So,
we're doing some of that, but it's hard for us to get.
Catalina Marketing, they're using AWS, but they're moving to Azure
Okay.
for their development. But they have their own physical infrastructure, data center in Orlando.
Right.
So they use the cloud for development, quick prototyping, and then deploy it into their data center. But then they're thinking of using the cloud as their DR strategy as well.
I mean, that's kind of like what I was saying, like what we're doing too. Like we have an internal development environment as well that we get VMs and stuff that we can run in our own data center. But we're using GCE for quick prototyping, like you were saying, spinning something up really quick, running some integration tests. It's probably better more for like developer testing than it's going to be for like a user acceptance testing or professional services testing or something like that, right? So
I mean, like internally, like for us, Clutter, I would say 70% of our boxes are in AWS.
Okay.
And we just have infrastructure. Like right now, I can log in and go like, I want this AMI and this version of CDH, and like all this stuff, and within 30 minutes, I just have a cluster, and I don't worry about it. That's what we do.
Right. No, that's great, and I'd love to have that model, but I don't think my company will do
I
it.
don't think
That's
they
my.
will either.
That's my.
Yeah, so it's a business decision, right? Normally that's what trumps tech,
It's
which sucks, but that's the reality.
It's also expensive though. You should see our bills.
Yeah, just be careful with cloud because you are charged on CPU time. Data, probably it's okay.
Mhm.
So, like for instance, the solution engineers at Hortonworks about 2 years ago, they have AWS's infrastructure, and within 6 months, we got billed for $500K. 6 months. And there's only like maybe 15 of us who's using it for prototyping,
Right.
not even production.
Wow.
So we decided to cut it and then build our own data center in our headquarters, and then use OpenStack to basically prototype.
Okay.
Yeah, so OpenStack or VMware or Docker. Yeah, so many choices, right? Which is great.
So yeah, that goes back to my point though. Like, I still don't think that there's like as complete of a private cloud solution as you're going to get out of GCE or AWS or whatever, right? Like, there are things that you can make work, but they're not going to have that same like experience like that you get out of a public basically.
So I think the Fed has an agreement with AWS because they're using them heavily. And so they probably don't make that available for commercial stuff.
Right.
Yeah, like is it NSA or one of the two?
NSA, I forgot the other one. Even yeah, even NASA. NASA uses AWS.
I know Aetna's got some healthcare applications running on AWS.
Yeah. It's funny. Amazon gets more money now from AWS than e-commerce.
That's crazy, right?
It's crazy. So February, forgot to mention this. We have Home Depot presenting. They haven't said what the details of the presentation will be, but I've asked that information. So before the end of the year, we should have that. And they're hosting it at their headquarters, which I think is in Smyrna. Is that right? Yeah. So we're really trying to push that 2 presentations each month. And if you know of anybody who'd like to present, let us know. Even you, if you are interested, let us know as well. So we'd like to have the community get rolling here. We've been slacking for, I guess, the past 12 months or so. Yeah. All right. So I think we ended up early, which is great because everybody gets home and spend time with their family. Thank you all for coming. And thank you, Matt, for presenting. Appreciate it.